Hi, it's Mr. Oliver, and today's video is about scientific notation. Now, you've probably learned scientific notation in another course, in another grade, perhaps in another school, but maybe we've forgotten it because we don't use it very much outside of science, and we're going to be using it enough in chemistry that it's worth us to review it a little bit. So first of all, what is it? It's, on one hand, it's a way of writing numbers that are either too big or too small. And we're always going to write them so that there's one digit in front of the decimal and all the remaining digits are behind the decimal, and then it's going to be multiplied by 10 to some exponent. As example there, 2.56 times 10 to the exponent 4. And this, of course, is going to be one number, but you'll notice that there's one number in front of the decimal, the remaining numbers behind the decimal, and then multiplied by 10 to some exponent. As I've already mentioned, it's convenient when we have numbers that are really large or really small. So if I have a very small number, and typically in chemistry our numbers are going to be smaller rather than very large, but if I have that decimal 0.00000000025, I think I counted the right number of zeros, that's not very convenient to write. So if I write it in scientific notation, 2.5 times 10 to the exponent negative 10, much more convenient. The other thing, the reason that I would want to use scientific notation is it's going to clarify the number of significant digits. So in the number 2000, that could be 4 significant digits. I would argue that it's only 1 significant digit, but it depends on the tool that I was using to measure it. If I were to write it in scientific notation, and I had the correct number of digits, significant digits rather, then I know from the number it's the same value, but it's also now correct for significant digits. Turn into your calculator, because you may have a new calculator since you last learned scientific notation. If you were to type a number into your calculator, a fairly small number, or alternatively a very large number, your calculator might automatically convert it into scientific notation, as this one did here. And your calculator expresses it like this, but what that means is 2.3 times 10 to the exponent negative 6. Now we're going to have to understand what is written scientific notation and also what is calculator scientific notation. So we have to learn how to work back and forth between those two. Well, how do we get to scientific notation? It's pretty simple, but we're going to go through it step by step. We already know that 1000, for example, is 10 to the exponent 3. Well, then 3000, I could think of that as 3 times 10 to the exponent 3, 3 times 1000. And if I had 3642, well, that would be 3.642 times 10 to the exponent 3, and now we have full scientific notation. And if I keep going with larger numbers or even just plain simply other numbers, I would be doing the same thing. One number in front of the decimal, remaining numbers behind the decimal, raise the appropriate exponent. And of course the appropriate exponent is, if I want to put the decimal point right behind the 4, I would have to move it from its original location here to 1, 2, 3, 4 places to the left. And that becomes an important blank that we need to fill in, an important pattern. If I'm moving the decimal point to the left, then yes, of course, I'm going to have a positive exponent. On the other hand, if I'm moving in the other direction, if I'm moving with the small numbers, I know that decimal 01 is 1 over 100. And 100 is 10 to the exponent 2, and I can write fractional exponents as negative exponents. Not fractional exponents, but exponents on fractions. Then decimal 04 would be 4 times 10 to the exponent negative 2, and decimal 0036 would be 3.6 times 10 to the exponent negative 3. And we could go even smaller, and I'm not going to count all the zeros this time, but I'm going to have 6.83 times 10 to the exponent negative 7. And I move the decimal point from its original location to 1, 2, 3, 4, 5, 6, 7 places to the right, so that I would have one number in front, remaining numbers behind. And of course we can fill in this last blank. If the decimal point moves to the right, when I'm putting it into scientific notation, then I'm going to have a negative exponent. Your calculator is going to be one of your more important tools that you use in chemistry, so make sure we understand how we use the calculator. Now, on the graphing calculator, which most of you probably have, the button that we're looking for is called EE, and it's not its own button, it is on top of, it's the second function to the comma, right above the 7, you'll notice. And when you hit that EE button, or the second function comma, to get the EE feature, it does the times 10 part for you. So if you want to type in 4.3 times 10 exponent negative 5, you would type in 4.3, easy enough, second function to access the scientific notation, the comma button, because the scientific notation feature is a second function to it, minus, and I actually shouldn't say minus, I should say the negative button down the bottom, and then the 5. Pretty simple. And when you do that, the display is going to be this, 4.3e, meaning scientific notation, times 10, negative 5, and that's my exponent. So if you're going to type that in your calculator, this is what appears on the, as you type it, and you hit enter, it's what appears on the calculator. What about mathematical operations? Well, I'm going to do the same thing. The calculator will treat this entire thing as one number. So if I'm using proper scientific notation on the calculator, I don't have to worry about running into orders of operations problems. 5.83, second function, negative 4, right? So I'm getting my 5.83 times 10 to the exponent negative 4. Divide by 46, hit enter, and I get this number. Now this number is quite long, and if we know about scientific notation, we'll see that we have it indeed written in scientific notation. It's kind of important to look for because we're used to just looking at the first few numbers and then maybe rounding off, and I'd be tempted to say 1.27 there. Actually, if I'm looking here with significant digits, I should only be writing 1.3, unless that's a exact value, and then maybe I would want 3 significant digits. However, I need to look all the way to the end of the number to see if I have scientific notation. So we do have to get used to looking at the entire number rather than just the first little bit of it. What if I want the calculator to be in scientific notation all the time? And what if I want the calculator to figure out how I get the correct number of significant digits? If I go to mode, I of course get this screen, and across the top of the screen in mode I've got the first line in the middle says sci, and that means scientific notation. So if I select sci, and then right below that I can select the number of digits that are going to appear, and actually I think this one is the correct number of decimal points rather than the number of digits. So if I want 3 significant digits, I would need 2 decimal points. If I want 4 significant digits, then I would have 3 decimal points. So in this case, I want 4 significant digits, so I'm taking 3 decimal points. And if I were to type in 96, it converts it automatically into scientific notation with 3 decimal points, 4 significant digits. Now, if I don't want 4 significant digits on that, I'd have to do something different, but if that's what I typed in, that's what I get. If I then do decimal 0035 and I hit enter, then it turns that into scientific notation with 4 significant digits. If you go to the course webpage, you'll notice that there is a worksheet on scientific notation. And the worksheet is available for you to download. If you feel you're comfortable with it now, you don't have to do it. It's not going to be checked. But if you think you want a little bit of practice, by all means, go to the course webpage, try out the worksheet, get some practice with it, make sure you know how your calculator works. Make sure that when you were to write this down as an answer to a test or something, you're writing 3.500 if you want the 4 significant digits, times 10 to the exponent negative 3. This is important. This is what you're going to write down for me. After that, enjoy the course and enjoy doing scientific notation. Thanks for watching.